Next up, we will have Olivia Clapp, and she is going to be talking about spilling the beans on soil carbon sequestration.
Globally, our soils store 4.5 times more carbon than trees. Yet, they're so rarely talked about as a strategy for carbon sequestration. And this is because we simply don't know enough about them. Understanding more about how our actions are impacting the soil will allow us to develop new carbon-smart soil policies. This is of particular importance when it comes to our agricultural practices, as agriculture is a major emitter of carbon. Currently, the major way of reducing this is through implementing new technologies and field management practices. But what if we could do this just by shifting the varieties we grow? Now, plant breeding has revolutionized our bean crops. We've seen improved disease resistance, drought tolerance, and have increased our yields by an average of 12.9 kilograms per hectare per year since 1909. We know we're improving the above-ground characteristics of our crops. What we don't know is the impact that this is having on the soil. To address this question, I'm going to be studying carbon sequestration and carbon metabolism in common bean. The process of carbon sequestration can be seen on the slide. This is when atmospheric carbon dioxide is captured by the plant during photosynthesis. This carbon then travels through the plant to the soil, and the roots release some of this carbon into the soil. To study this, I'm going to be using a method known as a decadal genetic gain study. These are commonly used in plant breeding to assess the impact a particular trait has had on breeding, but have yet to be used to look at carbon sequestration in common bean, despite it being eaten with any other legume. My study will grow 300 varieties released across the past 90 years. Physiological measurements will be taken on each of these varieties that will highlight any changes to the crop's photosynthetic efficiency and water use efficiency. I'm also going to be taking a range of soil health measurements. These, whilst informative on their own, can also be used as a proxy to measure soil carbon storage. All of the varieties I'm going to be using will be genotyped. This will allow me to look for genetic sequences that are linked to the impact a particular variety is having on the soil. If any of these sequences are found, they could be used to screen new varieties before release. Having this knowledge could allow plant breeders to ensure they only release soil-friendly plant varieties. It could also help to shift breeding away from a process that only focuses on above-ground characteristics to a process that focuses not just on the whole plant, but also on plant-environment interactions. In today's world, we're talking more and more about the importance of developing climate-sensitive agriculture. But in order to do this, we need to be looking at plant-soil interactions, as these represent a vital piece of the puzzle when it comes to lowering our CO2 emissions. Thank you.